Hello, everyone. This is the second of the series on building AI first organizations, agents, AI strategy, and governance. I hope you liked the first episode on modernization with AI. My name is Murtaza Chaudhry, and I lead product management in the agentic AI organization of Amazon Web Services. My work focuses on helping organizations move their applications from legacy systems to modern AI powered platforms safely and pragmatically. Over the years, I've seen how hard migration and modernization really is, and how agentic AI now is making it much faster and cost effective. And that's what inspired me to do this series, to share what's working, what's changing with Gen AI, and think about the landscape of Gen AI overall across building features and responsible AI in practice, how to build autonomous agents, and also how to think about product strategy with AI. This is the second of a four-part series. And today we cover responsible AI in practice. We have two more episodes after this about autonomous agents and leadership with AI. Here's the roadmap for today's session. We'll begin with why responsible AI matters, then unpack its core principles across fairness, transparency, and accountability. We'll look at how bias enters AI systems and what tools exist to detect and mitigate it. Next, we'll discuss how to operationalize governance so ethics become measurable practice. Finally, we'll close with the human element, how oversight and trust anchor every responsible AI system, and key takeaways you can apply immediately. Why responsible AI? AI is no longer confined to research labs. It's making real decisions that affect people's lives every day. Think about a loan approval model that determines whether a small business survives or fails, or a diagnostic AI that helps identify early signs of disease. These systems are incredibly powerful, but also deeply consequential. If the data they are trained on contains hidden biases, they can unintentionally reinforce inequality. For example, some hiring algorithms have learned to favor certain schools or gender patterns, not because of intent, but because of biased historical data. And responsible AI ensures every decision is traceable, explainable, and accountable, not a closed system. It builds a foundation of trust, which is essential not only for customers but for regulators and society at large. Without trust, even the most advanced AI system will face resistance. With it, we create systems that people can rely on safely, transparently, and at scale. Responsible AI is built on three interconnected pillars: fairness, transparency, and accountability. Let's start with fairness. It's about ensuring AI doesn't replicate or amplify bias. A hiring algorithm that favors resumes from one gender, or a healthcare model that underperforms for certain skin tones, both violate this principle. Fairness requires diverse training data and continuous bias audits to prevent harm. The second pillar, transparency, it focuses on clarity, helping people understand why an AI system made a certain decision. If an AI denies a loan, users should be able to see which factors influenced that outcome. Tools like model cards and explainability dashboards give developers and regulators visibility into the reasoning that AIs use. And finally, accountability. This is where principles become practice. It's not enough to say the AI made a mistake or someone must own that outcome. Accountability ensures human oversight, governance reviews, and ethical escalation paths that need to be put in place. And these three pillars together make responsible AI more than an idea. They make it operational, measurable, and trustworthy. AI adoption is growing at an incredible pace. Companies in every sector are embedding it into their products and processes. In fact, enterprise AI usage has nearly tripled in the past 3 years. But here's the paradox: while adoption is surging, trust isn't keeping up. Surveys consistently show that less than half of customers trust AI to make fair, unbiased, or transparent decisions. The gap between what's possible and what's trusted is what I call the AI trust gap. It's not just a perception issue, it's a performance one. Every time a model produces an unexplained outcome or a customer can see why a system made a choice, the gap widens. And as it widens, adoption slows. Responsible AI practices um, are the bridge to this, which is helping us close this gap by making AI explainable, equitable, and accountable. Fairness in AI isn't a single number, it's a continuous practice. Models trained on incomplete or biased data reflect the inequities of their source. For example, facial recognition systems historically struggled with darker skin tones because of underrepresentation in training sets. Or think of credit scoring models that penalize applicants from certain zip codes, not because of intent, but because location became a proxy for privilege. And true fairness means designing for equity, not just for accuracy. It's about asking who benefits, who is excluded, and who might be harmed. Fairness needs to become a mindset, one that spans dataset design, feature selection, and even how outcomes are communicated. Transparency is how we turn complex AI systems into understandable, trustworthy tools. It's about making AI's inner workings visible, not to everyone, but to the right stakeholders. For example, model cards describe what a model is designed for, its limitations, and performance across demographics. Similarly, data sheets explain where the data came from and how it was collected. Together, these practices help users, regulators, and internal teams understand not just what AI is doing, but why. When transparency is missing, trust breaks. But when it's embedded, it enables informed decisions, ethical oversight, and shared accountability. The third pillar of responsible AI is accountability. And this is where principles meet real world practice. AI can automate tasks, but it cannot carry responsibility. Humans, whether product managers, compliance officers, or engineers, are ultimately accountable for how models behave and impact users. Every AI system should have a clearly defined owner, the person or team responsible for monitoring, escalation, and retraining if issues arise. For example, when a financial model incorrectly flags legitimate transactions as fraud, accountability means there's a process for rapid review, correction, and communication. Accountability transforms AI from an experimental tool into a governed enterprise grade capability. It's the difference between using AI and owning its outcomes. Responsible AI isn't about perfect models, it's about balanced systems. When fairness fails, bias hides in plain sight. When transparency fails, people lose visibility and trust. And when accountability fails, no one owns the outcome and users pay the price. We've seen this across industries. Recommendation systems amplifying misinformation or hiring algorithms unintentionally excluding diverse candidates. Each case wasn't a single point of failure, it was a missing pillar. The takeaway is simple: responsible AI works only when all three pillars reinforce one another. If one cracks, the entire structure becomes unstable. Bias is not just a data problem, it's a life cycle problem. It can enter the system anywhere from how we collect data to how we label it, train on it, and even how we interpret feedback. For instance, if historical hiring data reflects a company's past bias, a machine learning model trained on it will inevitably perpetuate the bad bias. Similarly, if customer feedback loops reinforce only majority voices, the model keeps optimizing for the loudest users, not necessarily the most representative ones. That's why bias detection needs to be proactive, built into every phase of development, not bolted on later. Identifying where bias enters is the first step to keeping it from spreading. Now that we've seen where bias can enter the system, let's look at the four main types. First, data bias. This happens when the training data itself is unbalanced. For example, an image recognition model that's 80% trained on light skin faces will underperform for darker skin tones. Next, label bias. When human label introduces subjective judgment. Think of sentiment analysis models trained on social media posts. Sarcasm or cultural nuance often gets misclassified. Then, measurement bias. When we used a wrong metric to measure success. A customer service chatbot might be rewarded for shorter conversation times, but that could come at the cost of empathy. Finally, algorithmic bias, where model design or parameter tuning amplifies pre existing patterns. Even when the data is clean, the math can create imbalance. Recognizing these categories helps teams diagnose the root cause and apply the right mitigation strategy. We have talked about types of bias. Now, let's look at bias in the wild, where models meet the real world. A few years ago, a major tech company built a hiring algorithm to help screen resumes. It later discovered the model was consistently favoring one gender over other, not because of explicit gender markers, but because it learned patterns from historical hiring data where one gender was overrepresented. Another example comes from facial recognition systems, which have shown higher error rates for a gender or people of color due to training data imbalance. These errors are not just statistical, they affect people's lives from misidentification to denied access. Even credit scoring and predictive policing models can reinforce systemic inequities when the data reflects historical bias. The key insight here is that bias doesn't need malicious intent to exist. It emerges naturally unless we design systems consciously to detect and correct it. Once we understand bias, the next step is detection. Fortunately, we have powerful tools that make this visible. AWS SageMaker Clarify, for example. It automatically scans your data sets and models for imbalances. For instance, showing how prediction accuracy differs between demographic groups. And there is FairLearn that provides interactive visualizations where you can explore trade offs between fairness and performance. It helps you decide whether reducing bias slightly affects accuracy or not. And tools like Shap and Lime, they explain why a model made a particular decision, revealing the features that most influenced its prediction. The takeaway here is that bias detection should not be a post launch activity. It belongs right alongside training, validation, and deployment. Once bias is detected, the next step is mitigation. And this is where responsible AI moves from principle to practice. The first technique is data rebalancing, where we make sure the model doesn't overfit to dominant patterns. For example, oversampling underrepresented demographic data or applying class weights ensures more equitable training. Second, counterfactual data augmentation. Imagine tweaking input data slightly to see how the model reacts. If a credit scoring model denies a loan when a gender field changes, but all else stays equal, it's a red flag. Third, algorithmic regulation, where we embed fairness constraints directly into the loss function, so the model penalizes unfair outcomes during training. And finally, human in the loop review, where humans evaluate model behavior on edge cases that automation might miss. Let's bring these ideas to life with a real world example. A global hiring platform that relied on AI to screen millions of resumes each year. Initially, the model performed well on efficiency metrics, but when a fairness audit revealed a subtle gender and regional bias, the algorithm was prioritizing resumes that matched common patterns in certain geographies or historical hiring trends. The company implemented fairness audits using Clarify before every new model release, identifying imbalance across gender and location attributes. They also introduced human in the loop review for all high impact decisions, ensuring final selection involved human judgment. The result wasn't just better metrics, it was a broader, more diverse candidate pool and higher confidence among HR teams. Before we move on, I want to pause for a brief reflection. Think about your own context, where you are in product, data science, or governance. Which stage in your AI lifecycle do you believe carries highest risk of bias? Is it data collection, labeling, or deployment? What small process change could you make today that would have the highest long term impact? We've explored bias and fairness. Now let's discuss how organizations sustain these practices at scale. That's where AI governance comes in. Governance is the bridge between principles and daily practice. It translates high level values like fairness and transparency into repeatable, auditable processes. Strong governance frameworks define how AI systems are approved, monitored, and improved. They ensure that every model, whether built by data science or operations, follows a consistent review and accountability structure. When people hear the word governance, they often think of red tape, slow reviews, and endless checklists. Uh, but true governance isn't about bureaucracy, it's about clarity and confidence. A good governance defines who owns a decision, what criteria must be met, and how compliance is verified without blocking progress. Think of it as traffic lights, not roadblocks. They don't stop movement, they make movement safe and predictable. The most advanced organizations today embed governance into their pipelines. Automated reviews, bias checks, and explainability reports are part of CI CD workflows. And governance isn't one size fits all, it works across three interconnected layers. The strategic layer sits at the top. This is where leadership defines ethical principles, accountability structures, and clear ownership. Think of this as the why and who behind responsible AI. The operational layer, it translates those practices, those principles into practice, defining how reviews, audits, and escalation paths happen in the real world. Finally, the technical layer, it ensures implementation, monitoring data drift, logging model behavior, and documenting lineage. And when these three layers reinforce one another, governance becomes both scalable and sustainable, not just a checklist. Good governance isn't a box you check once, it's a living cycle. It starts with build, where you define clear principles and technical guardrails. Then comes review, where ethics, compliance, and risk teams validate readiness before deployment. Once in production, governance continues through monitoring, tracking performance, drift, and anomalies. And finally, improve, where feedback loops trigger retraining, updates, or policy refinements. This cycle keeps your AI ecosystem dynamic, continuously learning, adapting, and aligning with evolving ethical and regulatory standards. One of the most effective ways to operationalize AI governance is through a structured AI review board. This board isn't meant to slow teams down, it exists to provide multidisciplinary oversight. It includes members from product management, engineering, compliance, and legal, ensuring that every deployment meets ethical and regulatory standards. The board's job is to ask the right questions. Does the model align with our principles? Is the data ethically sourced? Are we monitoring its outputs responsibly? And these reviews should happen both before launch and periodically after deployment. One of the most powerful evolutions in responsible AI is the shift from policy documents to policy embedded in pipelines. Instead of relying solely on manual review cycles, organizations are codifying governance, embedding bias scans, fairness validations, and explainability checks directly into their CI CD workflows. For example, when a data scientist commits a new model code, an automated process can check for dataset imbalance, verify metadata completeness, and trigger an ethical approval gate before deployment. This approach, sometimes called policy as code, transforms governance from static oversight into a living, active layer of protection. It ensures compliance happens by design, not by afterthought. Responsible AI doesn't exist in isolation. It sits within a broader web of compliance frameworks. Many of the foundations for responsible AI, transparency, privacy, accountability, already exist within frameworks like GDPR, HIPAA, and the EU AI Act. Instead of reinventing governance, the goal is alignment. For example, GDPR's data minimization and consent principles can be extended into how we train and evaluate models. HIPAA ensures we handle sensitive data responsibly in healthcare. The EU AI Act introduces a risk based model classification approach that product teams can integrate into their review pipelines. The lesson here is simple: responsible AI doesn't replace compliance, it enhances it. Not all AI systems carry the same level of risk, and our governance approach shouldn't treat them as if they do. The EU AI Act popularized a useful way to think about this through risk classification. At the top, we have unacceptable risk, systems that inherently violate human rights or safety principles, like social scoring or manipulative surveillance. Below that is high risk, which includes use cases like medical diagnosis, credit scoring, or hiring, where outcomes deeply affect people's lives. There's limited risk systems, which might include AI that interacts with users but doesn't make critical decisions. Think customer service chatbots. And there is minimal risk, which includes day-to-day assistive AI, spell checkers, personalization, or recommendations. The the key insight is proportionality. The higher the risk, the stronger your oversight, documentation, and explainability that must be. One of the common questions we get about AI systems is, why did it make that decision? Explainability gives us that answer. It's about unpacking how the model arrived at its output. For example, if an AI denies a loan, we should know whether it was due to income, credit history, or an unrelated factor. Transparency takes this a step further. It's about sharing that reasoning in an accessible, responsible way with stakeholders, whether that's end users, regulators, or internal reviewers. Tools like model cards help document model intent and data lineage, while SHAP and Lime let us visualize which features matter most. And counterfactual explanations can show us what would need to change for a different decision, making AI behavior actionable and fair. The goal isn't to make every model fully interpretable, it's to make every decision understandable enough to build trust. We have covered principles, governance, and explainability. Now let's see how organizations are putting responsible AI into practice. In banking, institutions are integrating fairness dashboards to track credit approval rates across demographics. These systems don't just show outcomes, they actively flag bias trends before they escalate. In healthcare, AI diagnostic tools are reviewed by cross functional ethics committees prior to production, combining medical, technical, and ethical expertise. And in retail, personalization systems now implement privacy by design, ensuring data is anonymized and explainable even as recommendations become more precise. Even as AI becomes more capable, human oversight remains the foundation of trust. A human in the loop system ensures that people remain part of the decision process, especially in high stake domains like healthcare, finance, and customer experience. In healthcare, clinicians double check AI recommendations before diagnosis or treatment. In finance, analysts review model flagged anomalies to catch false positives. And in customer service, agents validate escalations when chatbots become ambiguous. The aim isn't to slow things down, it's to ensure context, empathy, and accountability, and make sure that it stays embedded in every decision. Explainability becomes real when we can actually see what the model is doing. The first method, feature importance heat maps. It helps us visualize which variables strongly influence predictions. For instance, in a loan model, income might have high weight where zip code should not. Next, decision trees. They turn complex models into readable logic paths, showing why one applicant was approved while another was not. And counterfactual examples, it lets us test hypothetical scenarios. If this input changed slightly, what would the output be? Once an AI system is live, the work doesn't stop. In fact, it's just beginning. Models learn from the world, and the world changes constantly. Data drift can occur as user behavior evolves or new contexts emerge. Without feedback, models can silently lose accuracy or fairness. A responsible AI system builds continuous feedback loops, capturing real world data, monitoring for anomalies, retraining when drift appears, and routing insights back to governance teams. For instance, an AI recommendation model might need retraining every few months as job markets shift. Similarly, customer experience models may need ongoing fairness checks as new demographics engage. Let's look at how responsible AI principles come together in one of the most regulated high stakes domains, healthcare. In this case, an AI diagnostic model supports clinicians by flagging potential anomalies in medical scans. But the system doesn't make autonomous decisions. Instead, it works in a feedback loop with human experts. Data flows from patients into the model, predictions are reviewed by clinicians, and validated outcomes feed back into retraining. What's critical here is traceability. Every decision from prediction to retraining is logged and auditable. And this structure ensures that models don't just improve accuracy, but maintain fairness and ethical integrity over time. Even the best AI systems can face ethical dilemmas, unexpected model behavior, unintentional bias, or unclear accountability. The key is not just to detect these issues, but to respond effectively through structured escalation pathways. In mature organizations, anyone from a developer to a product manager can flag a concern. That issue when moves through a transparent process involving the team review and AI ethics board or compliance or legal teams when necessary. Finally, executive oversight ensures that lessons learned translate into governance updates and training. Responsible AI isn't just a philosophy, it's a measurable discipline. These are examples of metrics leading companies use to monitor success. Let's look at some of them. The Fairness Index, which quantifies parity across demographics, ensuring that predictions don't favor one group over another. Transparency Score, it tracks how models have complete documentation for explainability. Bias Drift Rate, it captures how often bias reemerges after mitigation, signaling when retraining is needed. Human override ratio shows how quickly ethical issues are escalated and resolved. And finally, governance SLA tracks how quickly ethical issues. At this stage, responsible AI is no longer about frameworks or dashboards, it's about people. A strong, responsible AI culture means that governance isn't confined to committees. It lives in every meeting, sprint, and design review. Developers feel empowered to question data sources. Product managers openly discuss unintended consequences. And leaders demonstrate humility by acknowledging what AI cannot do yet responsibly. The four pillars of this culture are awareness, collaboration, accountability, and leadership. When these pillars hold strong, responsible AI isn't a checklist, it's a shared ethos across the organization. As we near the end of this session, let's talk about how responsible AI moves from principle to practice. Governance, bias mitigation, and explainability are not just artifacts, they are living processes that evolve with every product iteration. It starts with principles: fairness, transparency, accountability. Frameworks formalize how to operationalize those ideas. Processes ensure consistency across products and teams. Tools automate compliance and bias detection. And finally, culture sustains all of it, ensuring every team member sees ethics as part of their role. The companies that master this flow don't just comply, they lead with trust. To wrap up, let's distill what we have covered today into a few key takeaways. First, responsible AI is about continuous alignment, keeping your people, processes, and technology in sync. Bias will exist in some form, but it can be actively managed through retraining and feedback loops. Governance isn't red tape, it's how we build guardrails that enable safe innovation. Trust grows when AI systems are transparent and explainable. People trust what they can understand. And finally, responsible AI endures because of culture. It's not compliance alone that keeps systems ethical, it's the people who design and question them every day. As we close today's session, I want to leave you with this thought. Responsible AI isn't about compliance, it's about trust. Every data set we collect, every model we train, and every decision we automate represents a moment to choose responsibility over convenience. Start small. Add fairness checks to your workflow. Document model intent. Make governance visible, not invisible. When trust becomes part of your development culture, responsible AI becomes your default operating system. Thank you for joining me. And I'd love to hear your thoughts, questions, or even challenges. Let's keep this a real conversation.